Hello everyone, today we are going to talk about 95% IC retention stress and strain. In this video, we will cover key topics to explain the concept of 95% critical current retention. Firstly, we will define what 95% critical current retention means in the context of superconducting materials. Secondly, we'll explore the stresses and strains related to 95% critical current retention from electromagnetic, thermal, winding, and banding perspectives. Lastly, we will discuss the method of attaching 95% critical current retention phenomenon, highlighting where and why this property is crucial. During the winding process, the superconducting material undergoes stress and deformation. For example, around the central bending neutral axis, the inner surface of the wire experiences compressive stress, while the outer surface undergoes tensile stress. These stresses and deformations can damage the critical current capacity of the superconducting wire. We can define 95% critical current retention as the condition where the stress and deformation reduce the wire's critical current to no less than 95% of its original value. Under this condition, if the stress and deformation are relieved, the critical current can recover back to its original level. In this slide, we will explore several types of stress and deformation that impact the reduction of critical current in superconducting wires. These can be broadly categorized into four types: electromagnetic, thermal, winding, and banding. Each of these types is crucial for considering the mechanical impact on superconducting magnets. These concepts will be discussed in detail in subsequent chapters of our lecture. Understanding these factors is essential for the design and performance of superconducting systems. In this section, we'll briefly explore how 95% IC retention stress/strain is utilized. First, we measure the deformations that result in a 5% reduction in critical current. Below, you can see an example illustrating how tensile and compressive stresses lead to decreases in critical current. During the magnet design phase, these measured values are used to analyze the mechanical properties of the magnet. If the stress and strain on the designed magnet are found to be excessively high, a support structure may be implemented to mitigate these effects. In conclusion, the values of stress and strain at which the critical current is maintained at 95% of its original level are referred to as 95% IC retention stress and strain. These values are crucial during the magnet design process due to ensure the structural stability of superconducting magnet. You have to think about the supportive structures, considering these 95% IC retention value.